Everyone, myself Sriram Reddy. In the control systems, the topic is about transcranial magnetic stimulation (TMS). Introduction: Transcranial magnetic stimulation (TMS) is a non-invasive neuromodulation technique that uses magnetic fields to stimulate nerve cells in the specific areas to the brain. It works as the principle of the electromagnetic inductions, where a rapidly changing the magnetic field induces the small electrical currents cortical neurons, thereby modulating their activity. Originally developed in the mid 1980s, the TMS has become a valuable tool in both neuroscience research and the clinical therapy. Clinically, it is widely used for treating major depressive disorder, anxiety, and the certain neurological conditions like stroke rehabilitation, and the Parkinson disease. The technique involves placing a magnetic coil over the scalp, which deliver brief magnetic pulses to targeted brain regions by adjust, adjusting parameters such as the frequency, intensity, and the pulse duration. TMS can either excite or inhibit neural activity, offering insights into brain function and the potential therapeutic effects. Overall, TMS represents a safe, non-invasive, and reversible method for exploring and influencing brain activity, bridging the gap between neuroscience research and the medical treatment. Project overview. The project focuses on the design and the implementation of a transcranial magnetic stimulation (TMS) systems for non-invasive brain stimulation. The main objective to generate controlled magnetic pulses that can modulate neuronal activity in targeted regions of the brain. Key components of the project include the magnetic coil design, creating a coil capable of the product producing strong ion localized magnetic fields, pulses, generating circuit, developing electronic circuitry to deliver precise high intensity magnetic pulses. Control system implementing control system implementing a microcontroller based interface for adjusting pulse parameters such as intensity, frequency, and the duration. Safety mechanisms incorporating features to ensure safe operation and the prevent excessive stimulation. Testing and the validation, evaluating the system's effectiveness and the reliability for potential research or clinical application. This project combines electronics, neuroscience, and the biomedical engineering, aiming to create a functional TMS device that can be used for both experimental studies and the therapeutic purposes. Objectives. Here is a clear and the concise set of objectives for a transcranial magnetic stimulation (TMS) project. Design and develop a TMS coil capable of generating controlled and focused magnetic fields for brain stimulation. Implement a pulse generation circuit to deliver precise high intensity magnetic pulses with adjustable parameters, frequency, duration, and the intensity. Develop a microcontroller based control system for real time adjustment and monitoring of stimulation parameters, ensuring safety and reliability by incorporating protection circuits and the compliance with biomedical safety standards. Test and validate the system to evaluate the effectiveness, efficiency, and potential application in the neurological research of therapy. If you want, I can also draft a shorter 3-4 lines version suitable for slide presentation. Do you want me to that? To analyzing the circuit behavior and the varying of input voltage and the load currents and the validate the regularity, efficiency, and stability stability to build foundation for more advanced power supply design, including a variable regularities and the switching power supply. Prerequisites and the requirements. Prerequisites: basic knowledge of the neuroscience, understanding brain anatomy, neuron function, and the regions targeted and the simulation. Electromagnetism fundamentals. Knowledge of the magnetic fields, electromagnetic induction, and the coil design principles. Electronics and the circuit design. Familiarity with pulse generation circuits, microcontrollers, and the safety circuits. Programming skills. Ability to program microcontrollers. Example Arduino STM32 for controlling pulse parameters. Safety awareness. Understanding the biomedical safety standards for human and animal neural stimulation. Measurement and the testing tools. Ability to use oscilloscope, multimeters, and the other lab instruments for circuit testing. Requirements. Hardware requirements. TMS coil, a figure of 8 or circular coil for focused magnetic stimulation. Pulse generation circuit, microcontroller circular unit. Technologies used. Here's the technological used section for transcranial magnetic stimulation of the electronics and the circuit design. Coil, coil design and the electromagnetic figure of the 8 circular for focused circuit diagram. AC means isolation and the safety. Power supply and the isolation medical grade. Energy storage capacitor and the bank safe. Pulse switching, pulse forming network safe. TMS coil transducer placed over scalp. Patient and the operator give emergency steam and params. Control and the timing system, pulse rate monitoring and the feedback is triple sensors, coil safety or interlock stop patient. Intensity control temperature. And detailed design and the implementation, testing and validation is required for, and this conclusion is based on transversal magnetic of the magnetic system, testing and the validation for the microcontroller system, detailed design and the implementation. TMS coil type, figure of 8 coil for focused stimulation, circular coil, and the broader areas. Material copper wire would not be insulated core, low resistance and handle high currents. Inductance and the turns calculated based on the desired magnetic field strength, typically 1 to Tesla peak. Cooling air or water cooling may be implemented for repeated high frequency pulses. Pulse generation circuit. High voltage power supply changes a capacitor bank to provide required energy for magnetic pulse. Switching mechanism, MOSFETs and the IGBTs used to discharge capacitor through the core. Pulse control, duration, intensity, and the frequency pulses controlled via a microcontroller. Safety measure features, overcurrent and the over voltage protection circuits to prevent damage to components and ensure user safety. Microcontroller or the control system hardware. STM32 Arduino or the microcontroller board software program to trigger pulses, adjust the timing and the monitor system parameters. Interface, give or push button interface for real-time control for simulation parameters. Data acquisition, optional integration with oscilloscope or ADC, and the monitoring pulse waveforms. Implementation and the testing and the validation is done in the lab. And conclusion, transcranial magnetic stimulation TMS is a non-invasive of the program promising neurological modulation technique The magnetic fields to stimulate the specific areas of the brain, and it shows the significant clinical benefits and the testing various neurological and this disorders, particularly a major depressive disorder, anxiety, and the certain forms of the chronic pain. TMS offers the alternative for patients. Why do we not respond well to conventional treatments such as medication or psychotherapy? Yet research continue to advance the precision, safety, and the range of therapeutic applications of the TMS. Unexpected expand further. Overall, TMS represents the important step forward and the understanding the modulation of the brain function, providing the hope for forming, improving mental health and neurological outcomes.